Hi friends, this is Naresh. In this class, I am going to explain about engineering mechanics. And today's topic is area moment of inertia of C and U sections. These are the different shapes of channel sections, and this is U section. These two are channel section. Channel sections having unequal lengths. In this class, I will explain how to determine the area moment of inertia of these three sections. Before going to the class, first of all you have to know the fundamentals, that is centroid and moment of inertia. Here we are using a rectangular section, so therefore you have to know the centroid of rectangle and area moment of inertia of this section. This is a rectangular cross section having base capital B and height capital D. So therefore the area of a rectangle equal to base into depth. Therefore area of a rectangle A equal to B into D. And the centroid of an rectangle lies at where its diagonal lines meet to each other. Therefore the centroid lies here. The centroid lies at a distance of half of the base from x-axis and half of the height from y-axis. So therefore the given rectangle is symmetric about x-axis and symmetric about y-axis. Okay, therefore the centroid lies at a distance of equal distances, that is base by 2, base by 2, height by 2, height by 2. Okay, here x axis and y axis are the reference axis. Okay, x is the base and y is the left side edge. So here CZ is the centroid, whereas GX, GY axis are called centroidal axis. Therefore GX axis called centroidal x axis and GY axis called centroidal y axis. So the area moment of inertia of an rectangle about centroidal x axis, that is IGX, equal to base into depth power 3 by 12, that is BD cube by 12. Similarly, the area moment of inertia about centroidal y axis, that is IGY, equal to depth into base power 3 by 12, that is IGY equal to BD cube by 12. So these two are area moment of inertia of an rectangular section. Capital A equal to B into D is the area of a rectangle, where XC, YC are the coordinates of centroid. X is the distance of centroid from y-axis, and YC is the distance of centroid from x-axis. These are the general formulas for composite sections. Similarly, for composite sections, the area moment of inertia about base, that is x-axis, and the area moment of inertia about side axis, y axis. These are the two formulas we are using here. So therefore, where moment of inertia about x-axis, that is Ixx, equal to Igx plus area into yc minus y whole square. This is the parallax theorem. So for number of sections you have written same, so I repeat for number of times for n sections. Here I am showing for 3 sections. So Igx1 area 1 yc minus y1 whole square for section 1, Igx2 plus area 2 yc minus y2 whole square for section 2, Igx3 plus area 3 yc minus y3 whole square for section 3, where Igx equal to BD cube by 12 and area equal to b into d, and yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3, whereas y1 y2 y3 are the distance of individual centroids from x-axis. Similarly, area moment of inertia about y axis, that is Iyy equal to Igy1 plus area 1 into xc minus x1 whole square for section 1, and Igy2 plus area 2 xc minus x2 whole square for section 2, and Igy3 plus area 3 into xc minus x3 whole square for section 3. Okay, so here Igy is equal to db cube by 12. So area moment of inertia about centroidal y-axis, that is db cube by 12, and area equal to b into d, base into depth, whereas xc equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. x1 x2 x3 are the distance of centroids from y-axis. Now in next slide I am going to explain how to determine the area moment of inertia for C section. The question is determine the area moment of inertia of an C section. So the figure is given and the dimensions are here. For C section it contains 3 rectangles. One is vertical and 2 are horizontal, and the total height of a C section equal to 90 mm, and the base length of a C section equal to 100 mm, and the top length of a C section equal to 120 mm, and thicknesses are 20 mm for bottom, and this is also 20 mm for web, 10 mm for top. This is unequal flange, unequal channel section. Now first of all, the given section is split up into 3 rectangles. So therefore I am taking section 1 as a bottom rectangle having dimensions base b equal to 100 mm and height d equal to 20 mm. Therefore base b1, 1 refers section 1, b refers base. So b1, base of a section 1, b1 equal to 100 mm, whereas d refers depth or height of a rectangle. 1 refers section 1. So the depth of a section 1 d1 equal to 20 mm. So from here to here I consider as section 1. Now coming to the another section, that is vertical rectangle I consider as section 2. So having dimensions base of a second rectangle, that is b2 equal to 20 mm, and depth d2 equal to 60 mm, where suffix 2 refers section number 2. Similarly I consider the top horizontal rectangle as section 3 having dimensions depth of third section, that is d3 equal to 10 mm, and base of a third section, that is b3 equal to 120 mm. So these all are dimensions for determining the area moment of inertia and centroid. Now I am considering the reference axis, that is I consider x-axis at the bottom edge. This is x-axis, and I consider y-axis at left side edge. This is y-axis. So this is the origin. So the entire diagram is in first quadrant. Therefore the values of x and y are positive. Now in this slide I will explain how to determine the centroid. So for determining the inertia, area moment of inertia, you have to find the location of centroids, individual centroids. That's why I am determining the location of centroid. So from given diagram, I am here area of a yellow rectangle, that is area of a bottom rectangle a1 equal to base into depth, that is a1 equal to b1 d1 equal to 100 by 20 equal to 2000 mm square. Next, area of a second rectangle, that is section 2, base into depth, that is a2 equal to b2 into d2. So base 2 equal to 20 mm, d2 equal to 60 mm, that is a2 equal to b2 into d2 equal to 20 by 60 equal to 1200 mm square. The area of a top rectangle, that is section 3 equal to base, so depth d3 equal to 10 mm and base 3 equal to 120 mm. Therefore area 3 equal to b3 into d3, area 3 equal to b3 into d3 equal to 120 by 10 equal to 1200 mm square. These are the individual areas. The total area of a channel section A equal to A1 plus A2 plus A3. Okay, A1, A2, A3 are the individual areas. So area of a bottom rectangle equal to 2000 mm square, area of a middle rectangle equal to 1200 mm square, area of a top rectangle equal to 1200 mm square. Okay, this is the section 1, this is section 2, this is section 3. Suffix 1 refers bottom section, suffix 2 refers middle section, suffix 3 refers third rectangle. Okay, now this is the x-axis, this is the y-axis, and origin, this is origin. Now I am drawing the diagonal lines to locate the individual centroids. So the centroid of a rectangle lies at where its diagonals meet to each other. Therefore the intersecting point is called centroid. So C1 is the centroid of a bottom rectangle. Okay, C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis, y1 from x-axis. This is y1 from x-axis. So C1 is a centroid of a bottom rectangle at a distance of x1 equal to base by 2. From previous slide already we have discussed about basic principles. So for rectangle having centroid lies at a distance of base by 2 and height by 2. Therefore base by 2, that means b1 by 2 equal to 100 by 2 equal to 50 mm, x1 equal to 50 and y1 equal to half of the height. So height equal to 20 mm, so 20 by 2 equal to 10 mm. So y1 equal to 10, x1 equal to 50. Similarly I am drawing the diagonal lines for second rectangle. So these are the diagonals for a second rectangle, and the intersecting point is called centroid C2 at a distance of x2 from here to here. X2 from y-axis is half of the base, that is base 2 by 2, and y2 from x-axis. Here the value of y2 equal to sum of height of bottom rectangle plus half of the height of second rectangle. Therefore from here to here d1 plus from here to here half of the second rectangle. Therefore d1 plus d2 by 2. So y2 equal to d1 plus d2 by 2, and x2 equal to from here to here half of the base of second rectangle, that is b2 by 2. Okay, similarly for a third rectangle I am drawing the diagonal lines. C3 is the centroid of a top rectangle at a distance of x3 from here to here, x3 from y-axis and y3 from x-axis. Here the value of x2 equal to base by 2. So the base of a third rectangle by 2, that is base 3 by 2 equal to 120 by 2 equal to 60 mm. So x3 equal to 60 and y3 equal to the sum of height of a bottom rectangle plus height of a middle rectangle plus half of the height of a third rectangle, that is d1 plus d2 plus d3 by 2. So y3 equal to 20 plus 60 plus 5 mm. So this is y3. Okay, from this figure, x1 equal to, this is x1 equal to base by 2 equal to 50 mm, and x2 equal to base by 2 base 2 by 2 equal to 10 mm, and x3 equal to base 3 by 2 equal to 60 mm, and y1 equal to d1 by 2, that is 10 mm, y2 equal to d1 plus d2 by 2 equal to 50 mm, and y3 equal to d1 plus d2 plus d3 by 2 equal to 85 mm. So in next slide I have written these values in tabular form. So these are the section numbers, these are the section names, that is the bottom rectangle, middle rectangle, and top rectangle. These are the dimensions, and these are the areas, individual areas, and x and y values are individual centroids, where IGX, IGY are the area moment of inertia about centroidal axis, where IGX refers area moment of inertia about centroidal x-axis, whereas IGY refers area moment of inertia about centroidal y-axis. Already we have discussed about basic formulas. So for rectangular section, IGX equal to BD cube by 12, base into depth power 3 by 12. In similar way, for IGY equal to D into B cube by 12. Substitute the values, and these are the answers. Area moment of inertia. First of all, you have to calculate the value of xc and yc. Xc, yc are the coordinates of centroids. So xc is the distance of centroid from y-axis, yc is the distance of centroid from xx axis. Okay, so substitute all values in xc formula and yc formula. We will get the answers. Xc equal to yc equal to, xc equal to 41.81 and yc equal to 41.36. These two are coordinates for centroid. In this figure, I will show the position of centroid or center of gravity. Here C1, C2, C3 are the individual centroids, whereas CZ is the centroid or center of gravity of an entire C section. Okay, CZ lies at a distance of XC, XC equal to 41.83 and YC equal to 41.3 from X axis. Therefore, here I am drawing the GX axis and GY axis at centroid. These are the centroidal axis. Okay, GX and GY axis are called centroidal axis. Okay, these centroidal axis passing through the centroid or center of gravity. Now coming to the area moment of inertia formulas. From parallax theorem or transverse theorem, area moment of inertia about xx axis, that is base, that is equal to Ixx, and Iyy equal to area moment of inertia about yy axis, that is side edge. Now from general expressions, for 3 rectangles I have written 3 times for 3 sections. So Ixx equal to Igx1 plus area 1 yc minus y1 whole square. This is for section 1, from here to here for section 2, from here to here for section 3. Okay, from tabular form from previous slide, Igx1 area 1 yc minus y1 whole square, Igx2 plus area 2 yc minus y2 whole square, Igx3 plus area 3 y3 yc minus y3 whole square, and substitute all values in this equation. We will get the value of Ixx, that is area moment of inertia about xx, equal to 4778484.991 mm power 4. The units for inertia is mm power 4. Mm power 4 or meter power 4. Okay, distance power 4. Similarly, Iyy equal to Igy1 plus area 1 into xc minus x1 whole square plus Igy2 plus area 2 xc minus x2 whole square plus Igy3 plus area 3 into xc minus x3 whole square. And substitute all values in this equation, we will get the answer Iyy equal to 4892121.51 mm power 4. This is the final answer for area moment of inertia of an C section. Okay, xc yc are the centroid values and ixx iyy are the area moment of inertia about reference axis. Okay, these are the final values. Now coming to the another problem. Now I am going to explain how to locate the centroid of channel section, as well as I will explain how to determine the area moment of inertia of an U section. Okay, the given diagram is here, and the dimensions are the base of a U section or channel section. The base of a channel section equal to 100 mm, and height of a channel section equal to 80 mm, and the thickness of a channel section equal to 20 mm. So these are the dimensions of a U section. First of all, you have to split up this U section into 3 rectangles. Okay, now I consider bottom rectangle as section 1 having dimensions base b1 equal to 100 mm and height or depth d1 equal to 20 mm. So I consider from here to here and this thickness as section 1. Okay, 1 refers section 1 and b refers base, d refers depth or height. Okay, so now I consider this left side rectangle as section 2. Section 2 having dimensions base b2 equal to 20 mm and height from here to here. I consider from here to here, that is 80 minus 20, that is 60. So that depth d2 equal to 60 mm. Okay, this is section 2. Now I consider a section 3. I consider right side rectangle as section 3 having dimensions base b3 and d3 equal to 60 mm and b3 equal to 20 mm. This is section number 3. Now I am drawing the reference axis. I consider reference axis x axis at the bottom edge and y axis at left side edge. Okay, this is x axis, this is y axis, and this is origin. Okay, first of all you have to calculate the values of centroid xc and yc values. Then after you have to find the values of inertia values. So therefore the area of a bottom rectangle a1 equal to base into depth. So therefore b1 into d1, area 1 equal to a1 equal to b1 into d1, that is 100 by 20. So this is the area 1, area of a bottom rectangle, and this is section 2, area 2 equal to base b2 into depth d2. So area 2 equal to b2 d2. This is area 2. Now I consider third section, area a3 equal to base 3 into depth d3. So b3 into d3 equal to 20 by 60 is the area 3. So these are the individual areas for a channel section. Now this is x axis, this is y axis, and this is origin. Now I am drawing the diagonal lines to locate the individual centroids. So the intersecting point of diagonal lines is centroid, where C1 is the centroid of a bottom rectangle at a distance of x1 x1 from y-axis and y1 from x-axis. So this is x1, this is y1. Already we have discussed about formulas. So the centroid of a rectangle lies at a distance of half of the base and half of the height. Therefore x1 equal to base by 2 equal to 50 mm and y1 equal to half of the height, that is 20 by 2 equal to 10 mm. Now similarly I am drawing the diagonal lines for section 2 to look at the centroid C2. C2 lies at a distance of x2. This is C3, the centroid of section 3, and the value of x2 equal to half of the base, that is base 2 by 2. From here to here the distance is x2, that is a base 2 by 2 equal to 20 by 2 equal 10 mm, and from here to here the value of x3 equal to total base, that is 100 mm, and minus this value, okay, that is base by 2. So total base equal 100 mm, 100 mm minus from here to 10 mm. So 100 minus 10 equal to 90 mm. So x3 equal to base b1 minus b3 by 2, 90 mm. Now y2 equal to y3. Here the value of C2 and C3 lies on same reference line, that is this horizontal line. Therefore the value of y2 y3 are equal, that is half of the base from here to here, half of the base plus total height of a bottom rectangle, that is d1 plus d2 by 2. So y2 equal to y3 equal to d1 plus d2 by 2 or d1 plus d3 by 2. From figure x1 equal to base by 2 equal to 50 mm and x2 equal to base 2 by 2 equal to 10 mm and x3 equal to base x3 equal to from this from here to here b1 minus b3 by 2, that is 85 mm, and y1 equal to half of the height, that is d1 by 2, and y2 equal to y3 equal to d1 plus d2 by 2, that is 50 mm. And these are the section numbers, these are the section names, these are the dimensions, these are the individual areas, and x and y values for individual centroids. IGX, IGY are the area moment of inertia about centroidal axis. Okay, from general expressions, xc is the distance of centroid or center of gravity from y axis, and yc is the distance of centroid or center of gravity from x axis. Xc equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Now the answer is x equal to 50 mm. Similarly yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3, and the answer is yc equal to 31.81 mm. Now c1 c2 c3 are the individual centroids, whereas cz is the location of centroid for entire U section. So yc equal to 31.81. so from x axis to centroid the distance is yc equal to 31.81, and from centroid to y axis is xc equal to 50 mm. Now I am going to determine the value of area moment of inertia about base and side edge. From parallax theorem, Ixx equal to area moment of inertia about x axis, and Iyy equal to area moment of inertia about y axis. From general formula, Ixx moment of inertia about x axis equal to Igx1 plus area 1 yc minus y1 whole square plus like this. These are three rectangles, and the answer is 2532.121.51 mm power 4. Similarly, Iyy equal to area moment of inertia about y axis equal to Igy1 plus area 1 xc minus x1 whole square Igy2 plus area 2 xc minus x2 whole square plus IZY3 plus A3 into XC minus X3 whole square. Therefore, IYY equal to 366.67 mm power 4. These two values are area moment of inertia of an U section. Okay, these are the final values for U section. Now in the next slide I am going to explain how to determine the area moment of inertia for another U section. Here Gx, Gy are the centroid axis. Okay, now this is also U section but unequal lengths. Okay, U section also called channel section. Okay, the dimensions of U section are 100 mm base, 80 mm left side height and 100 mm right side height, and thickness 20 mm and 30 mm. This is also 20 mm. First of all, the given U section is split up into three rectangles like this. I consider bottom rectangle as section 1 having dimensions base b equal to b1 equal to 100 mm and height d1 equal to 20 mm. So I consider these two values. So b refers base and d refers depth or height. 1 refers section 1. Okay, now I consider the left side rectangle as section 2 having dimensions base 2 equal to 20 mm and d2 equal to, from here to here the total height is 80, but I consider from here to here only, that is 80 minus 20 equals 60. Therefore d2 equal to 60 mm. Similarly, I consider this right side rectangle as section 3 having dimensions to height or depth d equal to 80 mm. From here to here the total height is 100, but I consider from here to here only, that is 100 minus 20 equal to 80. So therefore the height or depth of a third rectangle d3 equal to 80 and thickness equal to, or base equal to b3 equal to 30 mm. Now I consider the x-axis at the bottom edge and y-axis at the left side edge. Now look at the, first of all you have to find the location of centroid. That's why I am taking the areas. A1 is the area of a bottom rectangle, that is A1 equal to B1 into D1, that is equal to 100 by 20 is the area of a bottom rectangle. So that is area 1 equal to 2000 mm square, and area 2 is the area of a left side rectangle, that is base 2 into depth d2. So A2 equal to B2 into D2, that is A2 equal to 20 into 60 equal to 1200 mm square. And this is the area 3 equal to base 3 into depth d3. This is d3 and this is b3. So therefore area 3 equal to 30 into 80, that is 2400 mm square. So these three are individual areas. Okay, this is x-axis, this is y-axis. I consider x and y-axis as a reference axis. This is origin. Now I am drawing the diagonal lines to locate the individual centroids. So therefore C1 is the centroid of a bottom rectangle at a distance of x1, equal to base by 2 from y-axis, and at a distance of y1 from x-axis, that is y1 equal to d1 by 2. Similarly, I am drawing the diagonal lines for section 2. C2 is the centroid of a second rectangle. It lies at a distance of x2. From here to here the value is x2 from y-axis, and from here to here the value is y2 from x-axis. So x2 equal to base 2 by 2, that is 20 by 2 equal to 10 mm, and y2 equal to the height of a bottom rectangle plus half of the height of second rectangle, that is d1 plus d2 by 2. Now I am drawing the diagonals for third section. C3 is the centroid of a second section, C3 is the centroid of a third section at a distance of x3 equal to total base minus half of the base. So total base of a bottom rectangle equal to 100 mm. So 100 mm minus this value, that is 15 mm. Now y3 is the value of distance of centroid from x-axis, and y3 equal to bottom height, that is d1 plus half of the height, that is d3 by 2. Okay, d1 plus d3 by 2. From figure, x1 equal to 50 mm, x2 equal to 10 mm, x3 equal to 85 mm, and y1 equal to 10 mm, y2 equal to 50 mm, y3 equal to 60 mm. Now in next slide I have written these values in tabular form. Okay, x is the distance of centroid from y-axis, y is the distance of centroid from x-axis. These are the section numbers, plane types, individual dimensions, and individual areas. X and y values are the distance of centroids from x and y axis, and igx, igy are the area moment of inertia about centroidal axis. Okay, igx equal to bdq by 12, igy equal to dbq by 12, and substitute these values in general expression. X equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3, and the answer is x equal to 56.42 mm. Similarly, yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3, and the answer is yc equal to 40 mm. Now c1, c2, c3 are the individual centroids, whereas cz is the centroid or center of gravity of an entire u section at a distance of yc equal to 40 mm from x-axis, and xc equal to 56.42 from y-axis. From parallax theorem, Ixx equal to area moment of inertia about base, that is x axis, and Iyy is the area moment of inertia about y axis. From general formulas, Ixx equal to Igx1 plus area 1 yc minus y1 whole square plus Igx2 plus area 2 into yc minus y2 whole square plus Igx3 plus area 3 into yc minus y3 whole square, and substitute all values in this formula. We will get the answer, that is Ixx equal to 4586666.67 mm power 4. Similarly, Iyy equal to 6515238.51 mm power 4. These two are the final answers for area moment of inertia. Okay, where gx, gy are the centroidal axis, cz is the centroid of a u section. Thank you.